guys, welcome back to Girl of Coders. This is Shristi Thakur and I am going to help you with your concepts in linked list. That is one of the most fundamental data structure and it is most used as well. So, I am going to present this. Okay, so here is the definition of linked list. So, what is a linked list? It is a linear data structure. As we all know that it is a sequence of elements that are called nodes. So what is the property of nodes? So first is it contains a data, that is a value. It can either be int or char, anything. And next is it has a pointer that links it to another node in the same sequence. So it is a reference to the next node in that sequence. Next is a linked list is of three types. So the first type is singly linked list, that is each node points to the next node in the sequence. In this case, the last node points to null, that indicates the end of the list. So the last node is not connected to the next node, so it is connected to the it is connected to null. And next is doubly linked list. So each node has two pointers, so one pointing to the next node and the another one pointing to the previous node. So this allows for the traversal in both the sides. And next one we all know, that is circular linked list. So in this type of linked list, the last node points to the first node, so it is forming a circular structure. It is like a circle. So this can be used in applications requiring continuous cyclic traversals. If you want to go from the last to the first linked list, first node of the linked list, so we are using circular linked list. So it is very different from arrays, as we all know that the array stores only element at contiguous memory location, but our linked list allows for more efficient insertions and deletions, because we need to update the pointers, so we don't shift the elements around. This makes the linked list very useful. So the insertions and deletion becomes more easy. So I would like to discuss the singly linked list. Singly linked list. So in this case, what happens, it is the most basic form of linked list. So each node, like this is a node and it is pointing to the next node, and that node is pointing to another node, and the last node, let's say this one, is pointing to null. So this is the example of single linked list. So all these elements, all these nodes are in a sequence and pointing to the next node. Next is doubly linked list. Doubly linked list. Linked list. So this is in this case, each node has two references, one to the next node and one to the previous node. So this allows for traversals in both the directions, in the forward direction as well as the backward direction. So this can be useful in certain algorithms where backward traversal is needed. So same as this. In this case, this is also pointing to here, and this is pointing to here. So this is doubly linked list. Next is circular linked list. So what is circular linked list? It can be either singly or doubly linked list, but the last node points to the first node and it forms a cycle. Like this node does not point to null, it is pointing to the first node. So this is useful for applications where we need a circular traversal of the list, like in round robin scheduling or anything like that. So I would like to ask that why do we use linked list? We have array. Why we need linked list? So first of all, first I would like to say that it gives a dynamic size. So these are very dynamic. Linked lists are very dynamic in nature. So they can grow and shrink at runtime. So this is in contrast to arrays which have a fixed size. So they must be defined at the time of creation, and this flexibility is very ideal for applications where the number of element is not known before. So dynamic sizing helps where we don't know the size. Next is efficient insertions and deletions. So like we can insert or delete elements in the linked list in more efficient way. So like if the operation is near the beginning or the end of the list, we don't need to shift elements like we would do in array. So we just need to update the pointers of that adjacent node. Next is memory allocation. Memory utilization. Memory utilization. So the linked list uses memory more efficiently and for larger data sets. Because they don't require contiguous block of memory, each node is like allocated separately in heap memory, and we can which can be more efficient depending on the use case. So this also means that the linked list can have higher memory overhead due to storing additional references. Alright, so this was the use case: dynamic size, efficient insertions, deletions, and memory utilization. So I would like to jump to the basic operations on the list. Like we can understand the operation is crucial for effectively using the linked list in our projects, and we'll be covering four primary operations like insertion, deletions, and traversal search. So yes, so what happens in case of inserting a node? First one, insertion. we are adding a new element to the linked list, we create a new node and we adjust the pointers accordingly. So let's see how to insert a node at the beginning, middle or end. Like we are adding a node either to the beginning or to any location throughout the linked list or to the end. So I have the code for this. Okay, so we can code it. Um, Class node taking a data node next a function int let's say and data is next null node head. So this is the head of the linked list. Next, we are making a method to insert a new node after a given node. Like we would be inserting a node at the front of the linked list. Let's say we can make a function for this. Let's say new node new. Let's say node. New node is new. Class new data. So new node dot next is here. So it is new node. Okay, which so next we can have a function to insert a node after this node. The first one. Public void insert after node previous node and new data. Okay. So if previous node is null, previous node is null, then we are printing that the given previous node can't be null, and then we are terminating it by return statement. Next node, new node, again new node we are forming new node, new say data, new node dot next is previous node dot next, and previous node dot next is new node. So this is it. Now we want to add a new node at the end of the list. So public void insert and new data value and new is new data. So if the head is null, return null. Head is new node new data, and then return new node dot next is null. Okay, so node का last is head while last dot next is not equal to null, then last is last dot next. Okay, and last dot next is you. Okay. So we just need to follow the main method and we need to update this. Okay. So now choose for the insertion one. What we are doing here, it is a code snippet in which we are making, we are initializing our data, and there's a node next. So this node method is taking our variable d, and the data is stored. The d is stored in the data, and the next, that is the data is pointing to null. Next is our class neglist in the work is happening. So there's a node head, and we're inserting at the front. So we are getting a new data, and we are forming a node, that is new node, and inside the new node, the new data is stored, and the new node is pointing to head, and then head is having the new node data. Next is public void insert after. So like the in this function, what we're doing is we are getting two variables. First one is the node, that is previous node, the node before, and the new data, that is to be stored in this node. So we are checking if the previous node is null or not. So if this is null, then we are inserting at the first node. So when this is null, then we are turning it out with the output that the given previous node can't be null. And next we are forming a new node, and we are storing a new data, and the new data points to next, and the previous node's next is having the data value that is stored inside the new node's next, and the previous node's next is the new node. Okay. So insert at the end. So we are forming a new node with this new data, and if the head is null, then we are storing the new data inside that head, and then we are returning it back. And if not, then new node's next would be null, and node's last would be node last is head. So last dot next is not null, then it would be executing last equals to last dot next, and last dot next is new node. So we are forming a new node, and yeah. So what is happening in this case is we are having a linked list in which we are having the head node, and then we are making a function delete node, and it contains a key, and the node temp now contains the head, and previous has null. Then if the head node itself holds the key to be deleted, then we are checking if temp is not equals to null and temp dot data is equals to key, then head is temp dot next. Now the head that used to contain the value now contains temp dot next. So we have changed the head. Now we are searching for the key to be deleted, and we are keeping track of the previous node. So we are now checking throughout the loop that if temp is not equals to null and temp dot data is not equals to key, then previous would contain temp, and temp would have temp dot next until we find the temp data as key. And if the key was not present in the list, then we would be returning it out, and we would be unlinking the node from the linked list. I think it is clear now. See, what we are doing is we are running a loop until temp is not null and temp dot data is key. Then we are changing the head. If the temp dot data is key, then head will be storing that temp dot next, and we are searching the key to be deleted, and we are keeping track of the previous node. So temp until temp is not null, then temp dot data and temp dot data is not key, then previous is temp and temp is temp dot next. So the value that used to be inside that linked list is now not taken into consideration, and we are forming the new list. Yeah, this is how we are deleting an element from within the linked list. So next is how we search inside a linked list, inside a singly linked list. So there is a class linked list, and there now we are having a node head, that is the head of the linked list, and now we are having a method to search a node inside the linked list, and this is public boolean search and node head int key. Okay, so we are getting these, the node head and the integer key, and node current is storing head. We are initializing the current, and now we are checking while current is not equals to null, then current dot data is key, and then we are returning the value data not found, and that is true, and current is current dot next. Like if if the data is found, then we are returning true, and we are traversing throughout the linked list to current is equal to current dot next, and if we don't find any value matching to that key, then we are returning false after the loop is throughout executed until current is not null. The loop continues. After that, the loop is pointing is terminated, and the return function return statement executes, and we are returning the value false. So this is how searching is done. So we have done insertion, we have done deletion, we have done searching. Now what next? So these are not really theoretical concepts, if I would say. They have practical applications too. So here are some of the practical applications, few of the areas in which you can use linked list. So first would be implementing stacks and queues. Implementing stacks and queues. Yeah. So we are like we can use linked list to implement stacks and queues data structures, and this is because they allow efficient insertions and deletions, which are essential operations for LIFO and FIFO, and dynamic memory allocation, The next one would be first was frequent. Next is we know dynamic memory allocation. So the operating system use linked list to manage free memory space. Whenever a program requests memory, the OS allocates a chunk of memory from the linked list of free memory blocks. And next is graph adjacency representation, GAR. So what happens is in graph theory, linked lists are used to represent adjacency list. So this is an efficient way to store graphs, especially when dealing with sparse graphs, as it saves memory compared to using an adjacency matrix. So next is undo functionality in application. So many software applications like text editors use linked list to implement undo functionalities. So each change is stored as a node in a linked list. So it allows the program to revert to previous states by traversing the linked list backwards. So what next? Let's wrap up the linked list session. I hope that this video helped you with your concepts in linked list. And if you have any questions, you can comment down. So thank you so much.